All right, another Newmann projection. I'm going to ask you to name this molecule. I'll put the name up at the end, so you can pause and work on that. And then I want you to draw a Newmann projection looking down C2, C3. So actually, while you work on that, I'm going to figure out the name of this thing. Okay, so name six-membered ring. It's easiest to just name that as a substituent. We have a 1, 2, 3, 4, 5-membered ring, or sorry, parent chain. We're going to do that as a substituent. So this is going to be 1, 2, 3, 4, 5. So this is, we have a 2-methyl and a 3-methyl. We have a 2-fluoro. We also have a 3-cyclohexyl. How's that? Cyclohexyl is a substituent. We haven't even had our 4th lecture. That's pretty advanced. So if you got the name wrong, that's fine. So then 2-fluoro, 2,3-dimethyl. You might be wondering, why doesn't dimethyl come ahead of fluoro? The DE is prefix, so you actually alphabetize that as an M. So then 3-cyclohexyl, 2-fluoro, 2,3-dimethyl pentane. All right, go ahead and pause and draw the Newmann projection, the most stable Newmann projection looking down C2, C3. Alrighty, let's put our eye right here. So if I'm looking down this way, I've got a methyl group down. Up toward the right is another methyl group. Up to the left is a fluorine. Okay, and so coming off C3, down to the left is a methyl group. You might wonder, there are 3 methyl groups here, and in the name, it only had dimethyl. One of the methyls is in the carbon chain. That's where that goes. Okay, so down to the right is cyclohexyl, and then coming up is an ethyl. That's a Newmann projection as drawn. So now you want to put the big group on the front carbon, anti to the big group on the back carbon. Big group on the front carbon. The methyls tie, right? 2 methyls are bigger than fluorine. Same row, more elements, or more atoms, so the methyl's bigger than a fluorine. Cyclohexyl versus ethyl versus methyl. You would be right to think that the cyclohexyl is bigger. It's actually significantly bigger. So these are the 2 big groups. You want to have them anti, and so what you would do is simply rotate this way, make sure they all rotate, and so we would get, that's going to keep the front carbon the same. All right, so methyl rotates to the top, ethyl rotates down to the right, cyclohexyl rotates over to the right. Big group on the back carbon, anti to the big group on the front carbon. That is the most stable Newmann projection for that, for looking down that bond.